Most beginner programmers focus on the wrong things, and I did the same. I remember obsessing over which language to learn, what course to take, and what project to build. But the truth is that these things don't matter much. What does matter is understanding the most important coding concepts, the ones that have always been around and always will be around. As programming languages have come and gone, these have stuck around. In this video, I'll walk you through 6 coding concepts every beginner must know. I thought long and hard about this and picked out the ones I wish I knew earlier in my coding journey. I've been an embedded software engineer for 3 years. During that time, I've spent 8 hours a day enjoying C++, struggling with C, and getting angry with CSS and web development in general. Having now spent over 6,000 hours programming, I thought it's time to share the most important concepts that might help you make fewer mistakes in your journey than I did in mine. The first concept is version control, which in practice always means Git, and most often also GitHub. When I was new, I didn't bother learning this. It was boring and didn't feel as relevant as actually writing code. This of course meant that when I started working a job, I had no idea how to document my work. I even remember writing every change I made to the codebase in a Google Doc, instead of just committing it to Git like a normal person. So if you have no idea what Git is, or don't feel comfortable with it, go learn it to avoid being as embarrassed as I was when I found out what it was. Properly learning scope was another thing I wish I did earlier. Have a look at this C++ example. It contains a global variable accessible everywhere, which you're probably very familiar with. But then, inside this function we have a static int called counter. This was the part that caught me off guard when I was new, because you see these from time to time, but what do they do? It's a variable local to the function that retains its value between function calls. This is unlike a normal local function variable that only stays in memory for the duration of the function. So every time this function gets called, it increments counter by 1, making it 1 on the first run, 2 on the second run, and so on. It's initialized only once and remembered forever. Knowing scope inside out is crucial, otherwise you'll be slowed down by having to constantly read the docs, and no one likes doing that. Another coding concept I wish I learned earlier was brutal simplicity. I will never lie to you and say that making something harder than it needs to be is desirable in any way. The easier and simpler you keep implementation while still making it nice, the less headache you will have over the long term. Simplicity goes hand in hand with the next concept: refactoring. Refactoring means reorganizing existing code to make it cleaner and easier to maintain, without changing what it actually does. It's very common to come across some crazy code when working on long-lived code bases, and it is often our job as programmers to tear that down and remake it in a better way. Be prepared to spend a lot of your days as a programmer refactoring programs. A very important concept when working with computers is the operating system. I never fully understood how operating systems worked until I one day was tasked with developing a Linux platform for an embedded device at work. Concepts like memory, file systems, and task scheduling may seem boring compared to making a fancy website or the next successful video game, but there's something every programmer must learn inside out. Separation of concerns is one of my favorite concepts. In plain English, it means separate your responsibilities, or else there will definitely be trouble about 6 months from now. Have a look at this terrible piece of Python code I wrote. It's got a function called process order that processes an order, sure, but it also implements 4 different tasks inside it. If tax rules change, or the pretend database turns into a real database, then we will have to change this function. This is called tight coupling and scales poorly. So how do we make this better? Start by defining one function for each task, then fill it with content. Finally, replace the logic inside process order with function calls, and now we're golden. When responsibilities are separated, changes in one part of the system don't ripple through everything else. And we can reuse any of this functionality in other places, which we weren't able to do before with the mega function. You may think this is obvious, but many large codebases have plenty of this lying around, so it's not going away anytime soon. Now sure, if you write code consistently for many years, you will learn these concepts slowly over time. But the earlier and faster you learn them, the easier your time as a programmer will be. And if you'd like to learn how to program things for yourself faster than anywhere else while also having a good time, then check out my speedy Python fast track course linked in the video description.